Okay, Chapter 9, Question 28. We have a math class with 25 students, 15 female, 11 male, and we want to look at some various probabilities of randomly selecting students out of this class. The first one we want to do is see what's the probability if we yank 3 students out that we get a male, a female, and a female. Okay. A male, then 2 females. So the probability of getting a male, well, there are 11 males out of 25. The fact that we chose a male means that there's 1 less male and there's also 1 less student. There's still 14 female students, but there are now only 24 total students. And when we go to choose the 3rd student, getting a female, we're going to have 1 less female, which gives us 13 out of 23. And so we can, let's see, we're going to multiply these all across. However, before we do that, let's see if we can do some reducing. 14 and, let's see, there's 2 goes into 14 twice, 7 times, sorry. 2 goes into 14 7 times, 2 goes into 24 12 times, so that'll make a 12 down there. Let's see, nothing with the 5, the 11s. I think that's about all we can do for reducing. And when we do that, 11 times 7 times 13 will give us 1001. 25 times 12 times 23 should give us 6,900. And you can turn that to a decimal and then to a percentage. I'll leave that as an activity for yourself, but this way you'll be able to check the answer in the back of the book. The B part, they're going to get the probability of getting a female, male, male. So the female first means we got 14 out of 25. 14 females, 25 students. There's 1 less student, so we're down to 24 students. There are still 11 males because we're getting the second one as a male. The third one will be a male, but we'll have 1 less than 11, so we'll have 10. And the total number of students has reduced down to 23. Now again, to do this calculation, we've got to try to reduce a bit, and we can do some sort of cross canceling, I guess. 14, 2 goes into 14 7 times, 2 goes into 24 12 times. Let's see, what else can we do? 10 has both a 2 and a 5 in there. So 5 goes into 10 twice. 5 goes into 25 5 times. 2 goes into 12. So 2 goes into 2 once. 2 goes into 12 6 times. So now when we do our multiplying, we do 7 times 11 times 1, which gives us 77. 5 times 6 is 30, times 23 is 690. So there's our probability. Again, you could turn that into a decimal and then a percentage as well, but this will allow you to check your answer in the back of the book. C. So now they want the probability of a female, female, and then a male. Okay. Again, just the counting. First female is 14 out of 25 because there's 14 females, 25 in the class. 1 female is gone, so now there's only 13 females. There's only 24 in the class because we chose the first student. After choosing the second student, there is now only 23 students in the class, but there is still the full number of 11 males. Again, we'll go multiply straight across, but before we do our multiplying, let's see if we can reduce. 14, 2 goes into 14, 2 goes into 24, 12 times. Let's see, no other common factors. So we're going to take 7 times 13 times 11, and it's kind of just like what we got up here, isn't it? 1001. It's just that the numbers are in different orders. So getting a male, female, female is really going to give us the same as female, female, male. It's just the fractions individually are different. And then 25 times 12 times 23 is still 6,900. Okay, doing okay? Let's see the D question. Is a probability of getting male, male, male. So the first male, 11 out of 25. Second male is 10 out of 24 students. And the third male is going to be, there's only 9 left out of 23 students. Okay. And then we can do some reducing here. Let's see. 10 will go into 25. It's got a 5 in there. So 5 goes into 10 2 times. 5 goes into 25 5 times. Let's see. 9 is in here somewhere. Well, it's 2 goes into 24 12 times. 2 goes into itself once. 9 has a 3 in it. 3 goes into 12 4 times. 3 goes into 9 3 times. So it should be 11 times 1 times 3, giving us 33 in the top. 5 times 4, which is 20. 20 times 23, we should get 460 for our probability there. And the final one is the E part, the probability that we get all females. So a little bit for everybody here. Females, we've got 14 out of 25. The second female, we're 1 female less and 1 student less, so there's a 24 students, and there is 13, and then there'll be 12 females out of 23 students. The problem took so long, my monitor went out on me. So let's see some canceling we're able to do here. Okay, 12 goes into 24. 12 goes into 12 once. 12 goes into 24 2 times. 2 goes into 14 7 times. 2 goes into 2 once. That's pretty much it. I think so. So then we get 7 times 13. 7 times 13 is 91. Yeah. 25 times 1 times 23 is 575. So there's our probability for E. A lot of work, but again, it's just a matter of counting through. And as we select one student, the numbers change on us, so we just keep track of that. You'll see this is a theme that runs through the next few problems.